Now, let me show you some magic that you can do with the vector product. Have a look at this triangle over here. U is here and V is here. How do I work out the area of this triangle? Well, the area of the triangle is half of the base times the height. But how am I going to work out the height? Well, if I know this angle theta, then the height is U sine theta, because that's opposite theta. So, the area of this triangle is a half times the base, which is the length of V, times the height. And the height is the length of U times sine theta. Which means the area is a half the length of U, the length of V, sine theta. But mod U mod V sine theta is U cross V, ignoring the direction. So the area of a triangle, if you know the two of the three vectors making up its sides, the area of this triangle is half the length of U cross V. There's a similar trick for a parallelogram, because a parallelogram is just double that triangle. How do I work out the area of a parallelogram? It's the base times the perpendicular height. Well, that's mod V times h. But h is mod U sine theta. So the area of the parallelogram is just the length of U cross V. And finally, you can also work out a volume. This shape is called, I'll try and pronounce it, a parallelepiped. Try it again, parallelepiped. It's like a rectangular prism, only it's allowed to be squashed over a bit. You don't need right angles. Of course, if you have right angles, this method will still work. So, we just worked out that the area of the parallelogram on the base is A cross B. It's the length of A cross B. But then to find the volume, well, the volume is that area times the perpendicular height of this shape. And what's the perpendicular height of this shape? It's this height here. It's the projection of C onto this vector. That should give you a hint of where we're going. It's C cos theta, which will give me this height just to there. That's the perpendicular height. How do I know it's perpendicular? Well, because A cross B will be perpendicular to both A and B, so it's perpendicular to the base of this shape. So, A cross B gives me the area at the bottom. It also incidentally gives me a vector perpendicular to these two. So now I can project C onto A cross B. It's the length of C cos theta. But wait a minute. A cross B times C cos theta is A cross B dot C. It's the scalar product of the vector product of A and B and C. Now, why are we still left with modulo signs here? Well, it's because the scalar product might end up being negative, but that's okay. We just want the volume. And of course, it doesn't actually matter which two vectors I start with before I go to the third. So we can define this as A cross B dot C. It's actually got a very fancy name, as your textbook notes. It's called a scalar triple product. Okay, why scalar? Because the result is going to be a scalar, it's a dot product. It's called the scalar triple product, but it doesn't matter whether you go A cross B dot C, or A cross C dot B, or B cross C dot A. It doesn't matter which three sides, what order I should say, it doesn't matter what order you put those sides down in.